So, you just ran your entire API test suite, and everything's green. Every test passed. Feels pretty good, doesn't it? But what if I told you that beautiful sea of green could be hiding a time bomb, a critical flaw just waiting to crash your application in production? Well, in this explainer, we're going to learn how to find those hidden flaws by designing test cases that go way, way beyond the happy path.
I mean, think about it. All your tests pass, that's great. But here's the question that should be keeping you up at night. Does that really mean your API is safe? Is it actually robust enough for the real world? And the surprising answer is probably not.
And this, right here, is the heart of the problem. We almost always build our tests for the perfect user, right? The one who sends a perfectly clean, valid JSON payload every single time. But the real world? It's messy. Real users, real client applications, they send garbage data, they forget required fields, they do things you'd never expect. If you're only testing for that perfect user, you're leaving the front door wide open for failure.
So today, we're going to fix that. We'll start by tackling the happy path problem and adopting a new mindset. Then we'll break down positive versus negative testing, show you how to build truly robust test cases, go over the common rookie mistakes to avoid, and finally, share the principles that'll make you a top-tier tester.
Okay, so how do we fix this? The key is a mental shift. We need to stop thinking like we're just testing software and start thinking like we're safety engineers. Seriously, this one change is the secret to building unbreakable APIs. To see what I mean, let's just imagine for a second your API isn't code. Imagine it's a bridge.
A positive test, that's like checking that your bridge can handle its maximum expected traffic load. You send a whole line of cars across, it holds up, everything works great. This proves the bridge does its basic job. That's your happy path. It's absolutely essential, but it's only half the story.
The other half of the story is negative testing, and this is where that safety engineer mindset really comes into play. What happens if a critical support column on your bridge fails? Does the whole thing just collapse into a catastrophic mess? Or does it trigger warning lights, close the lanes, and handle the failure gracefully? A negative test proves your API's robustness. It proves that when things go wrong, it doesn't just crash and burn, it fails safely and predictably.
So let's get a little more formal now and see how this actually builds out our testing strategy. Because understanding these core principles is what separates decent test coverage from truly great test coverage.
So here's the breakdown. Positive testing is all about valid data, making sure the API does exactly what it's supposed to do. Negative testing is the complete opposite. You are intentionally feeding it bad, unexpected, or just plain weird data to see how well it handles errors. And then you've got edge case testing, where you're really pushing the boundaries. What's the max payload size? What about null inputs or empty strings? A truly comprehensive test suite needs all three, no question.
And why do we go to all this trouble? Because this is how you build applications that don't fall apart in production. This is how you gain the trust of your entire team, your product managers, your developers, and especially your users. When you can prove that your API handles not just success, but failure, you become an incredibly valuable asset.
All right, enough theory. Let's get our hands dirty and see how we move from these ideas into actual automated tests. How do we build this stuff?
It really comes down to this simple 6-step blueprint. First, know your scope. Then brainstorm all your scenarios, the good, the bad, and the ugly. And for every single one, define exactly what you expect to happen. Only then should you start writing code, maybe parameterizing your data, and then finally organizing everything into logical test suites.
Okay, let's walk through a classic example, creating a new user with a post request. And we'll start with the positive test, the happy path. So for our positive test, we send a totally valid payload, but our assertions have two parts. First, we expect a 201 created status code. But, and this is key, we don't stop there. We also check the response body to make sure it contains the name we sent and a newly generated user ID. This is how we confirm the business logic actually worked, not just that the endpoint gave us a thumbs up.
And now for the part that finds the real bugs. Let's run a negative test. What happens if we try to create a user, but we conveniently forget to include the required email field in our request? Okay, here we expect a 400 bad request status. But listen up, because here's the pro tip. The one thing that separates the pros from the beginners, you absolutely must also assert on the response body. Don't just check for a 400. Check that the error message is specific and helpful, like email field is required. This proves your validation is working and that you're not leaking sensitive system info in your error messages.
And that brings us perfectly to the common pitfalls. Because, look, mastering the concepts is one thing, but avoiding these common mistakes is what really makes the difference.
Then number one rookie mistake, by far, is only testing the happy path. The second, as we just saw, is making vague assertions, only checking the status code. And the third big one is blindly trusting the documentation. Look, docs get outdated. A great tester uses them as a guide, but then they go further. They poke and prod to find the real-world breaking points.
So how do we pull all of this together to operate like the top 1% of QA engineers? Well, it really just comes down to a few key principles.
Here are some insider tips straight from top engineers. First, prioritize based on risk. Think about the blast radius. What's the business impact if this endpoint fails? You test your payment gateway way before you test the update profile picture endpoint. Second, use data-driven testing. All this means is you separate your data from your test logic. This lets you run hundreds of variations without writing a single new line of code. And finally, think beyond just function. Your parameters should be testing for security, performance, and reliability too.
And I am not exaggerating when I say this. If you can master this balance between positive and negative testing, you are already way ahead of the pack. It's the core principle that really separates the good testers from the great ones.
So let's wrap this up. What are the key takeaways? First, balance is everything. You need both positive and negative tests for full coverage. Second, validate the business logic. Don't just check inputs. And finally, your assertions are your proof. Always verify the status code and the response content.
You've totally got this. Start small. Just add one single negative test to your existing suite and see what you find. Once you've mastered this foundation, the next step is to scale it up. In our next explainer, we're going to dive deep into advanced test data parameterization to make your tests even more powerful. I'll see you there.